the time, it was one of the first distributions on CD was Red Hat. We had some Red Hat CDs, and at the end, they were queuing to have this chap sign them. And you were very young at the time, 20, 21, hardly out of short trousers. And I thought, hang on, something's going on here. So, you know, and here we are a few years later. You're still younger than me, but not by the same proportion. Okay. So, and I thought this chap's going to go far. He's going to, you know, he's going to turn into something pretty amazing. So anyway, I didn't write any of these questions. So I'm just going to throw them at you and see what happens. And if we run out of time, I'm just going to talk about my dog, Sydney. Okay, first question. Do you like your job?
Yes. I mean, my job has changed a lot over the 25 years I've been doing Linux. And that's part of why I like it. I don't do the same thing anymore. I was talking yesterday to the other Linus and other people around how if I never ever write another device driver in my life, I will be very happy because I've done that. I can't do it again. It's one of those things where I really loved doing it 20 plus years ago, and I don't do it anymore, and I don't want to do it anymore. What I do today ends up being not much writing code. I still do that for Git occasionally, but not very much for the kernel. But trying to make the process actually work is what I see as my job. And it turns out I always thought I was a complete geek and shy and didn't want to talk to people. And it's actually true, but when I can talk to people through email and I don't actually have to look at them, I'm okay. And I really enjoy doing communication. That's what I do. I read email, I write email. I try to get people to be on the same page. And when they're not on the same page, I try to nudge them a bit. And it's the greatest job ever.
No, it can't be. Mine's the best job in the world. No. Okay, I'll let you have that one. That's fine, I get that. Okay, a few years ago, you said some uncomplimentary things about the ARM maintainership. So how are we doing now?
I have to say, I mean, ARM has gone from being the biggest pain point in the kernel for me to being something I don't need to care about. And that's how I want it to be. I mean, the process is working. I mean, we all know about all the issues with all the vendors who add millions of lines of code and that never actually gets to me. And that part is not working, don't get me wrong, but that is not something I feel is the kernel community's burden to bear. That's something that I hope the vendors will end up fixing just because it's their problem, and I'm guessing it's such a pain for them that they will fix it eventually, so I'm actually hopeful. But more importantly, the part that we do and the core maintenance seems to be working really well. And if somebody disagrees with me about that, we should talk about it. But it seems to be actually going fairly smoothly, which is really nice to see, because I got very frustrated there for a while.
Yeah, I realized that at the time.
I'd like to say that, I mean, I am an outspoken person, and I used to say, and I still do, that on the internet, nobody can hear you being subtle. Sometimes telling people that, hell no, I will not pull from you ever again because this is not working. Sometimes you want to put it in those terms and really make clear that you can't be nice and subtle all the time. And then I'm certainly not known for being nice and subtle all the time. I do want to, when we have a problem, we need to talk about it very publicly and make sure people know it's a problem. So, you know, it's part of how I work, and I think it's actually important.
Yeah, I think your grumpiness is a tool you use in your marshalling of people.
Well, to be fair, I mean, sometimes my grumpiness makes more news than my being nice, really. I feel like most of the time I'm actually a very happy person. The process, and not just the ARM process, we have had a wonderful, I think, development process that actually really, really works. And 99% of the time, I'm a very happy manager, and I mentally pat people on the head all the time. And then that maybe then highlights the times when things don't work so well a bit more.
That's true. Okay. What are the biggest challenges facing the Linux kernel maintainership today? What are the challenges?
Actually, I think that's not a question you should ask me. I think that's a question that people should talk about and say, hey, this is not working for me. I think we're doing pretty well. We've had tons of issues with our whole development model and how we do things. But we've also had 25 years of kind of sanding the harsh corners down and making sure it works. The kernel is, if I just look at a lot of open source projects, the kernel development model clearly works really well. We have tons of maintainers. We don't have people stepping on each other's toes very much. We get new people all the time. We have every release, we have 1,000 people involved. That's enormous. I mean, I don't know, kernel people sometimes seem to dismiss how enormous that is. Because if you look at most other healthy open source projects, they may have 5 people involved at a time. I mean, the fact that I work with about 40 to 50 top-level maintainers is literally an order of magnitude more people than some projects have at any given time. So our process seems to be working, but there's always pain points, and I make sure that my pain points go away. And if people in the audience or know other people who grumble, talk about them. It's okay. I mean, you don't need to come to me privately. That's not the model we have. We very much have try to talk about publicly what does not work.
Okay, well, let's move off the people thing a little bit. Which bits, I mean, the kernel's been around a while now. It's been in this sort of steady state, continual improvement for a while now. Gone are the days of rewriting and big releases. We did away with that. It was exciting because there were so many big features to do, but now it's kind of steady state.
I actually disagree. And I'm really happy to disagree, because I thought we were in that steady state too. And we've actually had big, very core parts that have been rewritten even in the last few years. And what is actually impressive, how sometimes we are able to do that and nobody even notices, right? So clearly nobody notices.
Well, I didn't
we do some major surgery on some very low-level parts, and we don't make it a big deal for the release process anymore, and we end up making sure it works before it ever really gets into my tree, and it's still working. It was, when we compare to what the situation was in the 2.5 time frame or 2.3 time frame, where Linux was known for the whole even odd release schedule, that was horrendous. And it made people think that now we're doing these big changes, and we stopped doing that at 3.0 and said, this is not working. And now people think that we're all doing just smooth maintenance. That's not actually what's going on. We are still making core changes to very low-level stuff, and it's just that we've found a smoother model to do that.
Okay, now that's a fair point. I mean, the 5-6 years ago, most of the ARM stuff was down in Arch ARM platform 2. It's now in the right place in the kernel, so that's a lot of change. You're right. That's not a phrase I use very often, but there you are. But what are the areas of the kernel that you think need some radical but progressive change? Which bits need kind of sorting out?
It's not so much the areas that I think need radical change. There's always drivers, and don't get me wrong, a lot of drivers are really bad code. And sometimes it's because the hardware is really bad hardware, and the code just reflects that. And when I say bad code, I'm really not trying to make it sound like a value judgment. It's more of an issue where when you have one-off code that only works on one specific piece of hardware, it will not be as polished and good as the code that everybody uses across every single architecture and daily, right? So it's very natural, and it's something that I don't think we even should worry about. It's just always going to be the case. The places that tend to be things that I really think need reorganization, I mean, 5 years ago, it was ARM. We solved that. 6 months ago, it was RDMA and InfiniBand, and we have not solved that yet. There tends to go in like phases where certain subsystems, for one reason or another, become a big problem point, and I don't know what the reasons for that are. There's a new company coming in with new hardware or a new usage case, and it's just painful. And there's nothing really core that comes to mind. The shrinking thing is going to be interesting, and we'll see how well that works. It's a big problem for the kernel to try to fit into a small device, but
I think there's a lot of scope in networking, particularly how the kernel relates to hardware acceleration.
So I have to say, my personal hope is still that despite the fact that clearly Moore's law is slowing down and will be gone in 5-10 years, in some degree at least, I'm still hoping that we're in the situation that even in the IoT space, hardware will grow up. To the point where you will always have the endpoint stuff that is so small and needs to be so cheap and needs to be so low power that you're not going to run a real operating system on it. That's fine. That's not going away. But the places where people really want to put Linux in, I think it's going to be a meeting in the middle thing where, yes, we will shrink Linux, but I do think hardware will still grow up in the IoT space too. So people who want to fit things into 512K, maybe they'll realize that 3-4 years from now, it's hard to find those embedded chips that have 512K of embedded SRAM on them anymore, because it was just cheaper for everybody to grow the hardware a bit. So we'll see what happens.
Okay. This one, I love this one because he's filled the page. It's kind of, but it's a good question. It's a good question. It says there's ongoing work by Nicholas Petra, colleague over there, and possibly other parties to decrease the minimum size of the Linux kernel and resource usage to make Linux more suitable for low resources, low cost IoT embedded devices. However, even Nicholas, with his experience in contributing to the kernel, wonders if this will be accepted upstream.
So honestly, the hardest parts to get into the kernel, and I don't think this is particularly Linux specific, but I'm just saying the kernel in the sense that we've had this many times. The hardest parts are not getting new features or new drivers or new individual things that target one thing. The hardest parts have always for us been the things that are across the board, because then you have to touch tons of different code. You have to talk to every single maintainer. You have to maintain this code, not in a well-localized place, but across the whole kernel. And that tends to be a huge issue. And one of the problems with making a small kernel is exactly this thing where it's not a single subsystem. It's across everything. And you can always point to single subsystems that are particular pain points, but even if everybody knows that once you solve networking or scheduler or something, it's whack-a-mole. It's not like you're gonna run out of individual things to look at. So this is a fundamentally hard problem. And it's not so much the smallification per se, we've seen it before. Power management was a fundamentally hard problem for the exact same reason. It didn't touch everything, but it touched pretty much all the drivers and a lot of the subsystems. So anytime you have these kinds of issues that have overarching implications for more than just one subsystem, it's always going to be painful. And
power management touched not only difficult pieces of code, it touched the big egos as well. It's a difficult area to play in.
I think that's related to the issue that when you have to touch pretty much all pieces of code, you will hit the big egos as well. I mean, it's
naming no names.
Yeah. So it's just hard to get consensus when you have to talk to everybody.
With the with Nicholas' work, I think if you were to signal that it's a good place to go, that might help a little. I mean, hardware and pulling it in is good, but
the thing is, everybody agrees it's a good place to go. I don't think it's kind of like security. Everybody agrees that we want to be 100% secure. That's not the real issue. The problem is getting the manpower to do it, and one single person can't do it.
Not even Nicholas.
Not even Nicholas, sadly. Right? I'd love for it to be an issue where one person can solve it, but that's not going to happen. And so usually these kinds of issues, the thing I tend to look for is making, if you want to make big progress in a specific area, you need to figure out how to make lots of people care about that specific area. And that's the problem with small devices right now is it's really hard to find lots of people to care when most of the small devices you can buy tend to be very locked down, for example. And I'd love to say that there's millions and millions of IoT devices, so there should be tons of people caring about them. But if all these IoT devices are actually hard to play with, the only people who end up caring about these are inside companies. I mean, people like you. And that very much limits the scope of interest. And it means that all the other kernel developers who don't have devices that they can really personally care about will fundamentally not care. They will say, I'd love to make the kernel smaller, but they won't care. And there's nothing you can do to make them care. It's that doesn't happen on its own. You need to find the point to where people care because they have a personal interest. And it's really hard to get a personal interest in small hardware when none of the small hardware really tends to encourage that kind of loving.
Okay, well, we got some ideas there. Here's a rather cheeky one. I'm not sure I like to read this out, but I'm going to read it out. As you and many of the subsystem maintainers are getting old and crusty, do you have any plans to get young blood into areas of influence?
Get off my lawn. You know, I actually, so this has come up for a while now, that if you, for example, go to the kernel summit, which, I mean, the kernel summit is where all the maintainers go once a year, and you look at the average age, and it goes up by 1 year every year.
It doesn't quite look like the casino out there yet.
No, it does not look like. But the fact is, the core maintainers, they have been around for a while, and they tend to also like doing what they're doing, so they still stay around. So the core maintainers have been staying the same, and the average age clearly has been going up. But that's kind of unfair, because if you look at the people who go to the kernel summit, that is not actually the developers involved anymore. Those are maintainers. There's a few developers there, but almost all of us tend to be people who are major subsystem maintainers. And that group is very much getting older, and I think that's very normal. At the same time, if you actually look at the statistics, which some of us do every once in a while, so of the 1,000 people we have in every release, it used to be about half, now it's actually something like a third, send only one patch to that release. And that one patch is usually a single line or trivial thing. And many of those will never be seen again. But we actually, every single release, we still have new people come in who, even if they send only one single liner patch to that release, 1 or 2 releases from then on, they will send another one. And in a couple of releases, they they won't be on the single liner list anymore. They will be on the list of people who sent 3 patches, right? And it's a very skewed distribution. It goes from 1 patch to 2 to 3, and of the 1,000, if you look at just the top 50 or so, they're in a completely different class of people. There's a very long tail, and it takes time. And very few of the 1,000 people ever make it to the top. But if you have a couple every single release, and we do them every 2 to 3 months, we have new people come in all the time. But we do have the old people who are not getting younger. I mean, that's eventually we'll get so old that we'll just start drooling and having problem remembering people's names, which already happens, and we'll have to get young blood in the maintainership thing. But I think part of the issue is that we actually have a really good team of people who really like what they're doing, and they are staying around, so they are getting older.
Okay, which is no bad thing. Do you have a favorite architecture?
That's a very obvious question. I mean, x86 is still the one I favor most, and the reason for that is the PC. Not because of the architecture, it's because of the infrastructure, it's because it's there and it's open. And it's open in a way that no other architecture is. And it turns out the instruction set and the core of the CPU is not very important. And it's one of those big differentiating factors that people kind of fixate on, but it really doesn't matter very much in the end. What matters is all the infrastructure around that instruction set, and an x86 right now has all that infrastructure, and it has it at a lot of different levels. ARM obviously has it on the low end. There's no question that if you're in mobile, you are pretty much ARM, and we can start forgetting about MIPS and everybody else. I've been personally, obviously, pretty disappointed in ARM. Not as an instruction set, although I've had my issues there too, but as a hardware platform, it's still not very pleasant to deal with. And you know that much better than I do, I hope, right? It doesn't have the same kind of unified models around the instruction set that we have in the PC space. And it's getting better, I think. But part of it is just the market itself. If you look at even being compatible just wasn't as big of a deal for the ARM ecosystem as it has been traditionally for the x86 ecosystem. And when you don't have compatibility as being a huge deal for a hardware vendor perspective, you end up having a very fragmented market. And we can see what is the situation in ARM today. But realistically, today, obviously, x86 and ARM are the two big ones. Power has a lot of developers behind it, and IBM will support their architectures until the sun goes nova, or white dwarf, I guess. But we support pretty much everything. And I like the fact that we have a ton of architectures. I'm not emotionally really attached to any of the instruction sets. It really is more of a ecosystem thing for me, that where it really matters. Having developers on x86, for example, comes directly from the fact that we have a viable development platform on x86 in a way we don't on ARM. And I find that personally, I mean, and this is probably the greatest place to say that, that is my personal biggest disappointment with ARM, is that when I grew up, I came from a 6502 background. That was my first CPU. I would program 6502 in machine code, not assembly language. I would do it in machine code. I would do the hex numbers. I still know that LDA is hex A9, right? Because I would be able to write programs by hand in hex. What I wanted to upgrade to was the Acorn Archimedes, the thing that gave ARM its name, right? The thing that made the whole chip. The chip that actually took 6502 and said, what if we reimagine this and make it modern, right? The ARM really came out of, I mean, most of you, well, I don't know, some of you look young. ARM, back when I started, I was a 6502, like I really loved that architecture. The instructions were pipelined at a time where nobody did that, so that an instruction would take only one cycle and the next instruction would be fetched at the same time. Compared that to the Z80, which took like 4 or 10 cycles for every instruction. And it was like, no, that's the devil, right? And ARM very much came from the 6502 kind of mindset. The instruction set is completely different. The instruction set has nothing to do with the 6502, but it's the same mindset of pipelining with the RAM chips and actually getting high performance back in a day when you didn't have caches, right? This is, well, I was not there. I don't know any of the ARM designers. There are people here who probably know the people who designed this, right? But I wanted to have an Acorn Archimedes. That was my dream machine for a while. And why didn't I get one?
That's because you weren't playing this yet.
No, the reason was there was absolutely no infrastructure. There was all the things around the CPU were not there. I could buy an Acorn Archimedes in Finland. It was hard. Finland was not the center of the universe back then, but it was a situation where I made the mistake of going another odd British computer instead, the Sinclair QL, which was an even bigger failure than ARM or the Acorn. And after that, I just learned my lesson. Never, ever buy into something that doesn't have infrastructure. It's not about the instruction set. It's about everything around it. And the reason ARM people should care about this is you still do not have a development infrastructure. I can still, the original ARM machine was meant to be a desktop workstation for teaching people and for doing development. It is now 30 odd years later, and I cannot buy that machine with an ARM chip.
Okay.
Right. That is a disappointment to me, right? I love the concept of ARM. This disappoints me in a very deep, real sense. That I cannot find, I mean, I can find the toys. I love the concept of Raspberry Pi. I think it has the potential to really teach young kids and make IoT devices for old kids too, right? Don't get me wrong. But it is not a development machine. Everybody who develops for the Raspberry Pi will use a PC, x86, to do development. And I think that's a big, big deal. And ARM is not going to win until ARM can get to that point. That's my opinion, and I'm always right.
So, well, there's two of us are always right. That's good. Okay, thank you very much. I've really enjoyed chatting with Linus, so thanks to Linus.
So we're really, really happy that you came for a couple days to join us here. We heard a rumor that you do enjoy a nice spirit here and there, and Mad Dog couldn't be here, but this is something very special that was picked out, and we just want to say thank you so much for coming to Connect. We really appreciate it. Hopefully you'll join us again in the future.
Thank you.
Okay, so now we're going to go out and take a picture with Linus in the hall, a group photo together. So if you could file out the doors, and we're going to go in the hallway between the casino and the registration area.